So, welcome back. We are back at it again. Today we'll be doing a AppMaths paper, okay, set 12 from May-June 2021. So, without further ado, let's get started with our first question here. Quite straightforward because this one here is just basic indices. So, the first thing that I always do is to multiply out the brackets first, each and every one of them. So you will get the followings here, where the -2 multiplied to all the variables inside, alongside with the 1/3 here. Then the next thing is to change the divide sign into actual symbol. Then I repeat the same for the rest at the denominator. Okay, so this is the temporary results that I've gotten. Then the next thing for you to do is to compare those that is the same against each other. Then the one that I didn't shade will be compared together. So P -2 minus, because divide in indices represents minus. Okay, our -2 at the back, followed by Q, -2 minus 3, and lastly our R. Okay, because it has a multiply there, it means that we added 1/3, then minus -1. So through this calculation here, you will actually get your results as P to the power of 0, Q to the power of -5, and lastly, and you get the results as -2/3 for R here. Okay, pretty straightforward and easy question for 3 marks here. Let's go on with the next question. Okay, modulus function graph. So to make your life easier when you're illustrating this graph here, always ignore the modulus function first. So all you need is 4 minus 3x. Okay, then construct the coordinates that might help you to illustrate out the graph. When x is 0, y will be 4, followed by when x is 1, y will be 1. So through this scale here, you can roughly know that if, let's say, 1, 2, 3, 4. Okay, our points could be here. Then the other one is somewhere around here, most likely. Okay, so with this, we can start to construct the graph where I join these 2 points together. Okay, because of it being a modulus function, they won't accept any value that is negative down here. So I erase this excess part, and then I'm required to reflect it out. So before that, there's a few things that I have to label down. First one was that the points that they intersected here was 4. As for down here, I haven't figured it out yet. So I'm required to calculate it here by putting when y is 0, it will be 4/3. So let me write it down. Then it's time for me to reflect it back up. So the graph would look something like this. Okay, this could be how the graph would look like in your final results. Okay, so as long as your drawing is to scale, then you should be awarded full marks lah. So don't have to worry about it. So this is how it looks like. And let's move on to our next section here. So moving on to part B here, we are required to solve this inequalities with modulus. So instead of solving it directly with the inequality sign, I will just be doing this part first. Okay, I just put it as 7. And please remember, when you're trying to get rid of the modulus, you have to add a plus minus for the 7 at the back. So from here, let's proceed with our calculation. So it can either be positive 7 and also negative 7. So as we proceed with our calculation, you will get this as negative 1 as well as 11 over 3. Okay, and the question wanted us to find the value where it's specifically more than 7. Okay, so if you refer to the graph at the top, it looks like this. Okay, and when y equals to 7, maybe it's this line here. Okay, they wanted the value to be more than 7, so we have to shade this part and this part here. So clearly, when we trace it back down, here might be indicating our negative 1, and here might be indicating our 11 over 3. So the inequalities that fulfill this will be by having x lesser than equals to negative 1 and our x more than equals to 11 over 3. So that's how you solve this part B over here. Okay, rely on the graph will be the ideal solution for this particular type of question. Moving on to question 3 here. Okay, what they wanted us to do was to solve this vector question. First one was to identifying our OP in terms of A and C. But I have a particular habit, which is to always handle the excess value that they gave us here first prior to the calculation. The question specifically mentioned that AP and PC is in a ratio of 3 and 2. So based on this part, I can know that the entire vector that they were referring to was AC. Okay, and to find AP alone, you have to take it as 3 over 5 of AC, while PC alone represents 2 over 5 of AC. You might wonder, how did I get the denominator of 5 here? 5 is actually given to us by you adding up the ratio here. 3 plus 2 equals to 5. That represents the total ratio. Okay, so let's continue with the question. They wanted us to find OP in terms of A and C. So to get to OP, we might involve our OA followed by AP. Okay, so OA itself is just this lowercase a, but our AP here, like I said, through the excess value that they gave us, we are able to trace that it is part of AC. Okay, if you look closely, you'll notice that AC is not given. So this is the additional works that you have to do here, where you figure out that to get to AC, you have to start from A, went back to O, and then hit down to C point. Because there's a change of direction, okay, they wanted this way instead. So instead of A, it would be turned into negative A, adding up with C. Okay, let's put it in to complete our calculation here. So we have A 3 over 5 of negative A plus C. So through this calculation, we will get the results as 2 over 5A and 3 over 5C. Okay, so this will be it for our final calculation here. Moving on, we were being asked to solve OP PB is in the 2 to 3 ratio. Show that 2B equals to 3C plus 2A. Okay, so it's time to solve the puzzle again. They gave us OB this time around as the total here. Okay, and the total ratio was given as 5 again. Okay, so if I wanted to find OB, it will be 2 over 5 of OB, while PB will be 3 over 5 of OB. So with this out of the way, they now want us to find 2B equals to 3C plus 2A. Okay. So there's one thing that I noticed here. The question might be related because they wanted us to use this here. You saw this OP and you saw this OP repeated once again. So through connecting these 2 points, I would know that my 2 over 5 OB might be equals to OB that we identified. Okay, so our 2 over 5 OB here, if you were to skip reading the question, you might thought that what they gave us here was OP itself is B only. But the main thing was that the question told us that OB is the small b here. So with that, by substituting it in, and I get it as 2 over 5a plus 3 over 5c. All of them has a denominator of 5, which you can then get rid of it and arrange it in the format that they wanted. So I find this labeling in the graph slightly misleading. So if you don't have the habit to read through the question, you might fall for the trap here. So please be careful and don't repeat the same mistakes in your actual exams. Moving on to question 4, a curve, okay, d2y dx2 is given as 3x plus 2 brackets to the power of negative 1 over 3. The curve has a gradient of 4 at the point of 2 and 6.2. Find the equation of the curve. So the first thing that I noticed was that they gave us the dy dx and it was 4 when our x is given as 2. So with this information, okay, if I wanted to identify my dy dx, all I have to do is to integrate the d2y dx2 that was given by the question. So I know that by substituting this back in, you will be able to find the results. Okay, so let's start with our question here. Okay, first thing that will happen to integration is that you have to add 1 back to the power. So it was given as 1 over 3. If you were to add it by 1, you will get 2 over 3. Kindly take note that the values inside the brackets will never change. Okay, and I just put an unknown here, which is the results, okay, or the values that I'm trying to identify. So let's say this is what we have. After we differentiate it, we will get the final outcome as this. Okay, so let's try to differentiate what we have here, and then we run the comparison. So we have 2 over 3 multiplied with the unknowns, 3x plus 2, 2 over 3 minus 1, and also lastly, you have to differentiate the values inside the brackets. Then you will get an additional 3 there. So through this, 3 and 3 will cancel. So all I have left was 2 unknown, 3x plus 2, negative 1 over 3. So your final task to sort this question out is to compare this dy dx and the dy dx that you calculated. 1 over 3 matches up. 3x plus 2 also matches up. So all you have left was this 2 unknown compared to nothing here. Kindly take note, if there's nothing there, means it is 1. So our 2 unknown equals to 1. Unknown will be 1 over 2. So with this, I can key in my 1 over 2, and then I put a plus c here. So this plus c is basically the constant. Okay. So time to introduce our gradient back in, and also the value of x as 2. Okay. So your c value, you will get it as 2 at the end of the day. So this is part of the workings already. Okay, we are halfway through. Let's finish it up. So ultimately, they were asking us to find the equation of the curve, which means we are required to find y by integrating our dy dx. So based on the results that we gotten, it was 1 over 2, 3x plus 2 to the power of 2 over 3 here. Okay. And let's start all over again. Kindly remember there's nothing to do to the 2 at the back. You can immediately write it down as 2x. Okay, because it's just integer value, which means by integrating it, you will assign unknowns to it. Okay, so time to do the same thing again. 3x plus 2 never change. Your task was to add 2 over 3 with 1. Okay, then you get 5 over 3. So the other thing, let's put the unknowns in. Okay, so our dy dx was given as 1 over 2, 3x plus 2, 2 over 3. Our y is this here. Okay, repeat the same, find the dy dx of it. Okay, time to run the comparison. So you will notice that our 5 unknown here will be equals to 1 over 2. Unknown at the end of the day will be 1 over 10. So with this 1 over 10, I replace it out. Okay, so we get 1 over 10 now. And please remember, you have to add another alphabet in to represent the constant here. Okay, I just put it as D because I don't want to repeat the C twice. So now that we have our y equals to 1 over 10, 3x plus 2, 5 over 3 plus 2x's plus D. So time to sub in the points that was given to us. We have 6.2 as our y here, and then our x's here as 2. Okay, then you'll be able to find your D's results by taking 6.2 minus 1 over 10 with the brackets of 8 to the power of 5, 3. And also minus a 4 from it. So through this, you will get your D's value as -1. Okay, so your final answer for this question goes by 1 over 10. 3x plus 2 to the power of 5 over 3 plus 2x and minus 1. So this thing here is your final answer. So the steps is slightly lengthy. Okay, you have to manage your time properly so that you don't get stuck and remember the steps. Okay, the most crucial steps here is to remember to add in the constant. All right. Moving on to question 5a. Okay, so this is actually a logarithm question. Should be pretty straightforward here. Since the base is the same, okay, I can now just multiply them up. Plus means multiply, divide means a, minus means divide. We have 5p divided by 4 here equals to log a 20. Since both sides has log, it just cancel off. So we have 5p over 4 equals to 20. 20 multiplied with 4 divided with 5. You will get the results as 16 here. As for the next question, okay, so couple of things that I would do is to actually break it up. So we have 2x, okay, square, multiply with 3 to the power of 1 plus 8, okay, and then 3x minus 3 equals to 0. If you are easily confused by this type of question, it is best that you set 3 to the power of x as some other alphabet. So you can replace it as y if you wanted to. That's how I get 3y squared at the front, followed by 8y and 3 here. So through this, I will be able to run my, what we call this, factorization by keying in 3, 8, and -3. So through that, I get my y plus 3 as well as 3y minus 1 equals to 0. Okay, so let me double check. So we got our y equals to -3 or y equals to 3y minus 1 equals to 0, y equals to 1 over 3. But please remember, we are not looking for y here, but the value of x. So at the end, you're required to substitute it back. 3x equals to -3 and 3 to the power of x equals to 1 over 3. So if you were to use logarithm to trace the results, okay, base will be 3, -3 equals to x. So the first one, if I'm not mistaken, the answer should turn out to be invalid because we can't accept values, results value as negative here. So this one, it was mentioned, it is invalid. As for the other one, it's pretty straightforward. It's just -1. So just to prove that I'm correct, I'll be writing this down. Okay, so log 3, 1 over 3 equals to x. X will be -1. So only one answer here where x is -1. As for next question, okay, there's no, they didn't put in the same base for you. So it's up to you what you want to do here. Personally, I prefer everything to be in the same base. So maybe I will set it as log 2 because it's easier that way. So first thing that I'm going to adjust will be the value at the front here, where I bring back the 4 to it. Okay, then the next thing that I'm going to do is to change up the base, where I have log 2 to the power of 4 as well as log 2y. So from this, you will get the results as 4 over log 2y plus log 2y equals to 4. Okay, to make the calculation possible, kindly take note that you treat this entire thing as one entity. So when you introduce a function, introduce a fraction way, you will get this as log 2y being squared because it appeared twice. Okay, then equals to 4 log 2y. Okay, so from this, you can now replace it up if you wanted to. So set log 2y as x maybe. So I got x squared minus 4x plus 4 equals to 0. Okay, time to do the same thing again, factorization. 1, -4, and 4. So you get your results as x minus 2 as well as, oh, it's just x2. Okay. So since you got your x equals to 2, let's replace it back. Okay, so when you arrive at this step, all you have to do is to change it back into indices form, where you have 2 as the base, 2 as the power, and you get y. So that's how you find your y as 4 at the end. So this is pretty much it for you to solve this section C here. Moving on, we have question 6, where they were asking us about the stationary points of the curve. Okay, giving your answers in the form of a plus b square root 5. Okay, they want us to identify the stationary point. So whenever they mention stationary point, the first thing that comes into my mind is that I might have to differentiate this thing here. So to differentiate this, I have to bring out the power of x2. Okay, multiply with the 3 plus square root 5 at the front. Okay, and then the power of 1 here, bring it out. This 60 just cancel off automatically. So this is all I have left, and they want me to arrange it in a specific format. Okay, so to find the stationary point, dy dx will also be 0 by then. So you will have 2 bracket 3 plus square root 5 here, and then minus 8 square root 5 equals to 0. X will be 8 square root 5 divided with 2, 3 plus square root 5. Let's key in our calculator and see whether they can do the job for us. 8 square root 5, 2, 3 plus square root 5. Okay, it did. So you immediately notice that the answer here at the end of the day will be in this form that they wanted. It is negative 5 plus 3 square root 5. But okay, if you were to write this, you might not get the full marks because the question mentioned that do not use calculator here. So what they are expecting from you is actually for you to write this thing down. Okay, where you pretend you did the calculation here by putting in this indication. Okay, show them one more steps before you get the final answer. Okay, where you multiply it up. So you got 6 squared minus 2 square root 5 being squared. Okay, so 6 squared minus 2 square root 5 being squared. So you get 16 for that. As for the numerator, you have 8 times 6. You will get 48 square root 5 minus 8 times 2 times 5, which is 80 here. So just take out 16 from here, then you have negative 5 at the back. 48 divided 16 is 3, I suppose. Yeah. So 16 and 16 cancel. That's how you get negative 5 plus 3 square root 5 in the arrangement that they wanted. Hence, find the y coordinates of this stationary point, giving your answers in the format of c square root 5, where c is an integer. So now that we have the point of x as negative 5 plus 3 square root 5, okay, we are now required to substitute this back into the y equation that they have here. So I erase the 60 here. So you have to write it down. Y equals to 3 plus square root 5. Okay, and then x squared. And then minus 8 square root 5x. And then plus 60. Okay, so let's put it in. 3 plus square root 5. Negative 5 plus 3 square root 5 square. 8 square root 5, negative 5 plus 3 square root 5, and plus 60. So let's complete our calculation. So after we are done with the expansion of negative 5 plus 3 square root 5 there, we will get the results as this following here. So we actually have 70 minus 30 square root 5 plus 40 square root 5 with negative 120 and 60 here, if not mistaken. So expand it out. So I highlight all the numbers so that I don't miss them out during the calculation. 210 minus 150 minus 120 plus 60. So there's no more integers value there. So we have 90 plus 70 plus 40. So you get your final answer as 20 square root 5, which the C here is the 20 that they're referring to. So that's pretty much it for our B here. Moving on to section 7. Okay. So this is actually an NPR NCR question. And the moment I read the question, I know that first section that they were testing us here will be permutation, because they are creating a password where the arrangement matters. So when there's no restriction, there's total of 8 elements for us to choose from, and they only wanted a 6-character password. So all I have to do is to take 8p6. Then I will get to my results of 20,160. Section 2, they say it starts with a digit and finish with a digit. So 5p1 at the front, okay, and then 4p1 at the back. So after let's say 2 digits taken out was 8 and 9. I will have 6 digits left, okay, combining with the symbols, and I only need 4 of them. So I'm putting 4 here. Then this should get me the results. So the 5p1 is that I took from the digits at first. 6p4 is the remaining values that I can use, and 4p1 is this. So you get the final answer as 7,200. Okay. In section 3, the password starts with 3 symbols, which means all 3 was being used, and the rest of the 3 can be any of the digits here. So 5p3 to represent that. 3p3 times 5p3. So your final answer should be 360 for this. Okay, pretty straightforward, quite easy so far. Okay, moving on to part B. The numbers of combination of 5 subjects selected from n objects is 6 times. T. Numbers of combination of 4 objects selected from n minus 1 objects. Find the value of n. Okay. So the word here, combination. So NC5, okay, was what I derived. Okay, and this results here is 6 times when n minus 1 C4. Okay, this is what they were trying to tell us. Okay, so through this, you can expand it using the formulas that given you at the start here. This is what they are referring to. Okay, n factorial, n minus r factorial, and r factorial. So n factorial, n minus 5 factorial, 5 factorial equals to 6 times of n minus 1 factorial, n minus 1 minus 4 factorial, 4 factorial. So let's expand it out. Okay, so here we have n times n minus 1. I would just stop here. And then n minus 5 factorial, 5 factorial. I will stop here as well. N minus 1 factorial, n minus 5 factorial, 4 factorial. So I noticed a few things that was repeating. This one and this one gone. This one and this one is gone. So all I have to calculate was actually n over 5 factorial equals to 6 over 4 factorial. 6 divided with 4 factorial and multiplied with 5 factorial. So you get your final answer as 30. So it's not the usual way they phrase the question, but if you read it closely enough, pay enough attention to all the formulas that you have learned, this one wouldn't be too challenging so long that you didn't panic. quite straightforward. So this is our question 7's B solution here. Moving on, we have some linear law question. Okay, so they wanted us to try to find the value of A and B here. So the key assessment was actually located here. They wanted us to find log y plotted against log x. What it means that we are trying to frame our y here into this outline. So let's expand it accordingly. You get your log a plus log xb. Bring up the b here. Okay, so this is what you get. Kindly take note, this thing here is your y in your equation. This thing is the gradient. This thing is the x. And this thing here at the back is your y-intercept. So by calculating the gradient, we'll be able to use it to identify our b. So they gave us the point already, where it goes by m equals to b equals to our y2 minus y1 over x2 minus x1. So from this, you should be able to get the results. Okay, you will get 4/5 as your final answer here. Okay, or you can write it as 0.8 if you wanted to. This is for our B. Okay, now that you have B out of the way, you can proceed to identify your log A now. Okay, so I chose the point of 0.57 equals to 0.8, which is our B here. And then our 0.61, which is our X, equals to our log A here. So to find log A's results, we'll be taking 0.57 minus off with 0.8 times 0.61. So you get your log A results as 0.082. Remember, log in default will have a base of 10. So let's key in 10 to the power of 0.082. Then you get your A's results. 10 to the power of 0.082. You get it as 1.207813835511. Corrected to 3 significant figures. It will be 1.21 as your final answer here. Okay. So the next part, they were asking us to find the value of y when x is 3. So it would be easier if we use this because all the question is in the correct format. So A here is actually 0.082. The reason why I wrote it this way is because I wanted to avoid any premature roundings. So I just key in accordingly, 10 to the power of 0.082. Multiply with 3 to the power of 0.8. So you get your answer as 2.91 after correcting it to 3 significant figures. Okay, as for the other one, find the value of x when y is 3. I can still use the same thing if I wanted to. Let me think about it. So y equals to a x b. X equals to y over a. So let me fill in the blanks. They will be 0.8. Our y is 3. A is 10 to the power of 0.082. So you get 3.1181827768, which is approximately 3.12 if we were to set it in 3 significant figures. Okay, that will be how I solve our question 8 over here. We have our question 9a here, where they are asking for arithmetic progression. Okay, So they gave us our u1, which is negative 4. Okay, u1 here actually represents the a. Okay, so this is out of the way. And for our difference here is by taking u2 minus u1. Okay, so we have 8 minus negative 4, that will get you a 12, I suppose. Yes. So now with this a and d, we should be able to proceed with our sums calculation. Okay, so I don't have the formula. Hold on, let me pull it up. And my computer, where is it? Okay, so I found it already. It's referring to our Sn equals to 1 over 2n, 2a plus n minus 1d. Okay, so they wanted it to be greater than 2000, so remain unchanged, but our 2 here will be multiplied with negative 4. Our n remain unchanged, but we have a 12 here, and they wanted it to be greater than 2000. So the first thing that I get rid of was actually the 2 at the front. Okay, the 1 over 2 will be making the 2000 at the back into 4000. Okay, because divide becomes multiply at the back. And then plus 12n minus 12. So you have 12n squared at the end of the day, followed by 20n minus 4000 more than 0. So let's run our quadratic again. 12 minus 20 minus 4000. So your n possible value will be negative 70.44. Then you can write invalid for this because there's no negative n terms here. As for the other one, they mentioned that it must be more than 19.109. So, which obviously, as long as it exceeded 19, then we must take the next one, which is 20 here. So n will be 20, so that it is smallest and greater than 2000. Okay, so this is how we get the results here. As for the next question, which is our section B here, they gave us the 7 and the 9 terms of a geometric progression. Okay, 27 and 243 respectively. So they gave us u7 equals to 27. This is ar to the power of 6 equals to 27. As for the other one, we have u9 here, which is 243. ar8 equals to 243. So to find your a, okay, doesn't seem relevant here. They wanted us to find a common ratio. So all you have to do is to take ar8 divided by ar6, which is 243 divided by 27. Then you get r squared left. Okay, 243 divided with 27, you get 9. R's value will be plus minus 3. Okay, and they mentioned that it was positive, so 3 will be the only relevant results here. And then going on to the next one, find the 30th term and give your answers in power of 3. 7th term, you get it as 3 to the power of 4. A 3 to the power of 3. Then 9th term, 3 to the power of 5. So which means if it's 30th term, it will be 3 to the power of, minus it by 4 will get you 26. Okay, how do I notice this? It's because I backtrack. At the 7th term, it is 3 to the power of 3, and 9th term is 3 to the power of 5. The difference here is power of 4. Okay, between the n and the results there. So by taking the term minus it by 4, it will result in the power. So there's no calculation required for this, but instead whether your attention to details is there or not. So that's how they track and get it as 3 to the power of 26. Explain why the geometric progression 1 sine theta sine square theta, okay, has sum to infinity. Okay, I will have to try to find the common ratio first. So u2 divided by u3, you will get it as sine u3 minus divided by u2. Sine square theta over sine theta, you will get it as sine theta. Even if you did u2 divided by u1, you also get the same thing. Okay. So from this, so now that we have our common ratio as sine theta, so let me double check. If I were to set it as pi over 2, you get 1. And if it's a negative, you get negative 1. So if we refer back to the formula table that we have, they told us that for it to be valid, okay, our R modulus must always be lesser than 1. So if let's say, then I have to test to write it down. If I say my sine theta, okay, is always 1, because when I put in pi over 2, I get 1. When I put in sine negative, I get negative 1, which modulus of it will still be lesser than 1. Okay, that's how I'm going to write it. Okay, where my R will always be 1. Okay, it's just these two points here should be valid enough. Okay, with this calculation attached. So I won't be erasing this 2 here, I'll just keep it there. Moving on to question 10. So we have sine, okay, cosec square, cosine sec square, and they ask us to find the results here. So the first thing that I noticed was that what can I change my cosec square into? Okay, so our cosec square can be written as sine square. Okay, while the one at the back, we can write it as cosine square. So through this, you have 1 sine plus 1 cos. Okay, then from here, when you try to rearrange them and make the denominator the same, you will have this thing here. Okay, but because of 0 being on the other side, okay, you will have this at the end of the day. Okay, because here multiply with 0 will still be 0. I transfer the cosine to the other side. Then sine over cosine, okay, will be negative 1. So sine over cosine is actually tangent. Okay, so from this, let's try to work it out. They gave us a range specifically. It is from 0 to pi, and then 0 to pi on the other side. Okay, so far should be correct. For tangents to be negative, all's good. So we have answers here and answers here, most likely. So let's track it from our calculator here. Make sure it's in radian mode. You get your first answer as negative pi over 4. I will keep these answers here because we have negative range. So this answer is a valid one. And for us to get to the other side, kindly take note, this gap here is pi over 4. So all you have to do is take pi minus pi over 4. You should get your answer as negative pi over 4 and 3 over 4 pi. So these two should be your final answer. Moving on to part B, they ask you to show that it is equals to 2 sec theta. Okay, so let's try to make the denominator the same first. So we have 1 minus sine theta and a cosine theta here. As for numerator, however, it now becomes this, and 1 minus sine theta, 1 plus sine theta. No, they are the same. So it was being squared then. Okay, so with this, let's continue. We're not done with it yet. So I remain the cosec square unchanged because I'm unsure what would turn out at the back. So 1 minus 2 sine theta plus sine square theta. Okay, so this is all I have left. Expand it out. So you will have plus sine square theta, and then our 1 plus 1 minus 2 sine theta. Okay, so sec is actually related to cosine, which means I try not to move the cosine and just change the cosine square that was given to us. Okay, so cosine square can be written as 1 minus sine square theta, okay, plus sine square theta plus 1 minus 2 sine theta. Okay, through this, you will notice that minus cancel, and there is 2 plus 2 minus 2 sine theta. Now, take out the 2, then you have sine theta left. And they cancel off. 2 over cos theta will result in 2 sec theta. So that's how you get this 4 marks question here done. So looking at the final and one last question here. So kindly take note. The only changes between this part and this part was that they used a different symbol and the range was extended. So 3 of these will make it until 540. Okay, and the other thing to take note was that you can replace it now into this form instead. So the reason why I didn't use sec is because you can't key into a calculator. So just use cosine instead. So 2 over 4 equals to cosine 3 this. So 3 equals to cosine inverse 2 over 4. So please change your calculator mode back into degree before you proceed with your calculation. So 2 over 4 would actually get you a 60. So kindly take note, if you were to draw it out, okay, you have to draw another one which goes by 360 to 540. So the first answer, cosine is positive. Okay, you check it by looking here. Positive tells us that you have 2 answers at the first cycle and 1 answers on the second cycle. So the first one, 60 here, will be a valid result. Then you turn all the way down here. Okay. That would be 360 minus 60. Okay. And then one last one will be from 360, you go another 60 more. This part is 60. This part is 60. Last but not least, please remember to divide everything with 3 so that you get your final results. So these 3 things here will be your final answer. Okay, that's how you get this section 2 here done. So a bit confusing, but after practice a while, you will notice that a few characteristics here. Questions always connected, and it is best that you draw out the quadrant so that you can identify the answer faster and easier. Okay, let's look at our last question. So to mention the normal to the curve. So first thing that I will write down will be my normal formula. So the A here is actually the x coordinates given by the question. Okay, the so-called FA is basically asking you to sub in the original equation, but with 2 replacing all the x there. So you get it as learn 6, I suppose. Okay. However, for f prime, you have to find your dy dx. Okay. But it is a bit troublesome because you have to do your quotient rule here, where you have learn x squared plus 2, and then your vx is 2x minus 3. Your u prime of this is you copy back the denominator first, and then you differentiate the denominator, you get 2x at the top. Your vx, however, is just 2, quite straightforward. So let's complete our dy dx here by keying in the formula. You have your 2x minus 3 being squared. Then you have your 2x minus 3 multiply with your 2x, x squared plus 2, and then you minus it off with 2, learn x squared plus 2. So with this, your so-called f prime, okay, which is your dy dx with 2 substituted in, you will get the following. So just fill in the blank first. 2 times 2 is 4, so it's 1. Nothing for you to do at the front, okay, because they are cancelled off entirely. Then this one is gone, basically. And then you will get 6 at the bottom, and then you have learn 6 again. Okay, so let's finish it up. 4 over 6 minus learn 6. I don't think there's anything for me to calculate except for writing it in a different format. Okay, the denominator here is also cancelled because it becomes 1. So time to fill in the blank. So we have our y equals to learn 6 minus 1 over 2 over 3 minus learn 6, and then x minus 2. So they wanted us to figure out meet at y-axis. Okay, when we meet at y-axis, it tells us that our x will be 0 by then. So we have learn 6 minus 1 over 2 over 3, learn 6, 0 minus 2. So let's key in our calculator. Learn 6 minus 1 over 2 over 3 minus learn 6 again, and then multiply it with negative 2. So you will get your final answer as 0. Okay, so I noticed I wrote something wrong here. I overlooked the 2. Okay, so there should be a 2 on every single part here. with this correction, we should be able to get the results. So our final answer is 1.106088881688. If you were to correct it into 3 significant figures, you will get it as 1.11. So please don't repeat the same mistake like I did here. So the 2, okay, remember to put it in, then you should be able to get the results. Okay, overall, I would say this question here is rather easy. Okay, this entire set basically. It is tricky in this question 9C. Okay, if you're not familiar with the formula, how it works, then you might not be able to do it. And the other question that is slightly tricky will be this one here, our 7B as well. Then this one, the search question is slightly troublesome. This 6B as well. Then that's pretty much it. Okay. So if you have friends that are struggling, feel free to share this to them. And I wish you all the best in your upcoming examination. Thank you. Bye-bye.